Welcome to day 5 video. Um, all right, so we're going to be simplifying complex fractions. You should have this, I think it's on the back of one of your worksheets. So find this page in your packet. If you don't have it out, you want to hit pause, go find that packet, or get a blank piece of paper so you can just write some problems down. All right, so we're going to do, I think, probably 3 together, and then I'm going to ask you to do 2 more on your own. And you're going to bring those into class and we will check them. Now, complex fractions are a little scary looking, but we are going to tackle them with confidence. So we have a fraction in the numerator, and here we have a sum of 2 fractions in the denominator. Now, we know how to deal with when we have a fraction divided by a fraction. We can just change it instead of a vertical kind of path, we can change it and make it look horizontal, and it then becomes easier. But let's look at some strategies we can use here. Our number one strategy is multiply by a form of 1. Notice there is no equal sign. I can't do the same thing to both sides because there are no 2 sides. So my number one strategy is going to be multiply by a form of 1. And you guys all understand that a form of 1 could look like x over x, or x plus 5 over x plus 5, right? We've been simplifying out all of those things, but maybe sometimes we're going to need to put it back in to get a common denominator, right? So here, because we're adding these 2 fractions, we need to have the same denominator. And as I said in the last video, we want to look at both of those denominators. We have a factor of x, we have a factor of x plus 2. Well, there's not much to list out here, it's just x and x plus 2. So what we still need, oh, I was just going to change colors. What we still need here is a factor of x plus 2. And what we still need here is a factor of x. So we're going to go ahead and do that. We're going to multiply. So our first step, we want to get anything that is a sum or difference to have the same denominator. Here, find the same denominator, get them to have the same denominator. So here, we want to get these 2 to have the same denominator. I'm going to multiply by a form of 1 right here. And what this denominator is missing is a factor of x plus 2. And I can't just do it to the denominator, I have to do it, whatever I do to the denominator, I have to do to the numerator. So I'm going to multiply by this form of 1. And over here, I'm going to multiply by this form of 1. Why would I multiply by that form of 1? Well, it's what was missing. So we're going to have the same denominator, and our new denominator is going to be x times x plus 2. I'm just going to leave it as x times x plus 2 for now. Okay, so we're going to have a new denominator. Ooh, let me erase this. And we're going to add what's in the numerator. So here 1 times x is just x, and this distributes, be really careful, we're going to add 2x and add 4. So I'm going to combine 2x plus x really is 3x. All right, so our new denominator of this larger fraction is that. Now, I guess there's a couple ways of doing this. I never really thought of it like that. I'm going to show you a new method of solving this, or simplifying this, but we could actually do what we've done in the past. This is now a fraction divided by a fraction. We could change it and go 2 over x plus 2 times the reciprocal of the denominator, or of this whole chunk, the denominator. So we could write x plus 2 over 3x plus 4. And when we simplify, we would get 2x in the numerator and 3x plus 4 in the denominator. So that's one method, but I'm going to show you another method. All right. Once you get here, I want you to notice and focus in on the denominators of each. The denominator of the numerator and the denominator of the denominator. So when we're focusing on that, we want to ask ourselves again, okay, well, how could I get rid of them? I want to multiply by a form of 1. This whole thing, I want to multiply by a form of 1 that could make that whole thing disappear. Well, to get that whole thing to disappear, I'm going to need to multiply times that whole thing. Right? So here, this is in the denominator. This is going to be really in the numerator of my denominator. Am I confusing you yet? All right, and then this is also in the numerator of my denominator. I guess I could do it like this. Watch. Over 1 over 1. Then maybe it's a little more clear. Okay, cool. So really, I'm multiplying by this very complicated looking form of 1, but really, I want to get rid of this, and in order to get rid of this, I need to have x and x plus 2 in the numerator. So instead of multiplying by just x, well, I'm multiplying by x times x plus 2, but I made it look like it's in the numerator so you can see it a little better. That these are going to cancel out, and those are going to cancel out. They become 1, and what's left in the denominator is 3x plus 4. Here, as well, we get x plus 2 simplifies, but here we still have an x, so 2 times x is 2x in the numerator. So either of these methods I get the same answer. Whichever one I guess works for you is good. We can practice both kinds of strategies. All right, let's try the next one. I think I'm just going to try 2 with you and then ask you to try 1. All right, so here I want to get the same denominator and I want to get the same denominator. We're going to focus on 1 first and then go to the next. So here I have an x squared. To get an x squared here, I'm going to multiply by a form of 1. X squared over x squared. Now, why did I choose that? You're probably thinking right now, because you need to have the same denominator. All right, so in order to subtract something, we have to have the same denominator. Got to get that to have the same denominator. So we have 16x squared, right, divided by x squared minus 1 over x squared. So my goal, even though I know I could simplify that, I don't want to simplify that because my goal was to get the same denominator. Now that is the case. I now have the same denominator. I can write it as 1 fraction, 16x squared minus 1. All right, so that is my numerator. Now I could factor this, and we will look at that in just a moment, but let's just kind of stick with what we're doing. We got the same denominators. Now we want to get the same denominators down here. Use a different color. So we need this denominator to match this one. So I need to multiply by 4x squared over 4x squared. All right, so now they're going to match. And we're going to have it all over the same denominator, 4x squared. So we're going to have 1 minus 16x squared over 4x squared. All right, so we do that subtraction, and then what's left is 1 minus 16x squared. All right, so we have a fraction divided by another fraction. Woo, fun stuff. All right, now we could, again, do it in one of 2 ways. We could look at our denominators and, in a sense, cancel them out by multiplying by what's going to cancel that and what's going to cancel that. So we want to cancel both out in one try. So on our one shot, we could cancel out 4x squared. So I'm going to multiply here by 4x squared. Remember, that's in the numerator, right, over 1. And I'm going to multiply by 4x squared up here. And again, that's in the numerator of this fraction over 1. You don't need to put the over 1, but if it helps you see that that's in the numerator, oops, sorry. And this is in the numerator, that's in the denominator. All right, so once we do that, we're going to get rid of, this whole thing. So we're going to we're multiplying by a form of 1. A very interesting looking form of 1. But this and this simplify, and what remains here is 1 minus 16x squared. What remains in the numerator, the x squareds cancel, but the 4 remains. So we've got 4 times 16x squared minus 1. All right. Whew, this is a big problem. Okay. Now, hopefully by now you've noticed something special about this. 16 is the same as 4 times 4, x is x times x, x squared is x times x, and 1 is 1 times 1. We have a difference of 2 perfect squares. So we've got a factor of 4, we've got 4x plus 1, and 4x minus 1. Whoa! Down here we've got 1 minus 4x and 1 plus 4x. Oops, that's supposed to be an x. All right, check it out. Now, this is tricky. We have to be careful. What is the same and what is different? What can I cancel out? What can I not cancel out? Here, 4x plus 1 and 1 plus 4x. Is that the same or is it different? With addition, it doesn't matter if what the order is. So I could rewrite this 4x plus 1. These really are the same factor. But here I have a negative 1, and here I have a negative 4x. So those aren't the same, but I can make them the same. In order to make them the same, I want to change the sign of this and this to a different number. Actually, let's change the sign of this. It doesn't matter which one you choose. But if I want to make this into a negative 4 and a positive 1, I have to factor out a negative 1. So in the numerator, I have 4 times negative 1. And this now are the same, positive 1 and negative 4. So in the numerator, what we're left with is just 4. Wow, that was a big problem. All right. I want you to try one. I know they look very complicated. We will spend a good amount of time working on these, and this is a little more complex than I think we're going to go. I will look into problems that are a little simpler, but let's try it. Okay, I want you to go ahead and hit pause, try number 11, and then check your answer. All right. All right, this would be the answer for number 11. Notice the form of 1 that I used was the largest, right? It had all the factors. It contained all the parts of the denominator, the 2, the x plus 1, and the x plus 1, which canceled this whole denominator out. It only canceled out the 2 here, so x plus 1 times x plus 1 still remained, and I had to multiply it times 1. And here, so this applies to both pieces. You want to make sure one of them cancels out and 2 of them don't. All right. So come in with some questions. We will we will definitely practice this and work on this. I know these are very complicated, but I'm very confident you can do them. All right.